A very good evening, everyone. So, we welcome you to this cutting edge computer vision workshop hosted by Saras AI Institute. We are thrilled to have you join us for this exciting journey into AI, where you learn from the industry expert and compete for a whooping 2 crore prize pool in the biggest AI-thon of the year, Clash of Titans. Let's dive in and unlock the incredible potential of computer vision together. So we are honored to have with us Mirza Rahim Baig as our instructor today. So Rahim is a renowned data science expert with around 14 years experience in solving complex business problems using AI and machine learning. He is the author of 3 well-received books. In addition to his writing, Rahim is a distinguished teacher and a subject matter expert at various edtech platforms and institutes. His expertise covers AI, business analytics, visualization, Python, and machine learning. Rahim is also a mentor at a startup accelerator and serves as visiting faculty for MBA programs. We are excited to have such an experienced and knowledgeable professional with us today. So please join me in welcoming Mirza Rahim Baig. Over to you, Mirza.
Thank you, Hina, for the generous introduction. There is a raised hand. I don't know. If someone has a question already. Okay, that's down. Okay, all right. And again, good evening, everyone, and welcome to I would say, the official kickoff of this biggest hackathon of the year. Yeah, and we are already joined by 400 plus people. I believe they'll keep joining. So yeah, we are in a big group, competing with the best um, engineering institutes from India across the board. And yeah, good luck, everyone. So today, what I will try to do is, let me share my screen first of all. What we'll do today together is go through some fundamentals, or essentially some sort of a, let's say, crash course for you all, so that you can, to enable you to quickly build something for the hackathon. Yes. So today will be a crash course in computer vision. And I will talk about what all we will cover very shortly. But yeah, let me share the screen. So yeah, this is a workshop. Yes. At the same time, it is also the kickoff for the Clash of the Titans. And my own introduction has been given by Hina, so thanks a lot, Hina, for that. I think I would like to briefly describe myself as just some data person who likes to solve business problems. I've been doing this for 14 years. I've been doing, let's say, all kinds of roles really in data science. There's not one role I've missed. So data scientist, analyst, product analyst, business analyst, decision scientist. I've done all of those. So so now I just call myself a data person, yeah, and I think that's a good enough description. So that's about me, and I also teach, like Hina mentioned, I have 3 books, and I'm also like a mentor at Generative AI Startup Accelerator. And what we do today together is, first, this is the agenda. First, we discuss the outcomes for today. Within this, right, after discussing the outcomes, we will and pre-processing, which will be useful for you later. Then we come to the core of the technical part, which is the different kinds of models or computer vision. And then a very important thing called transfer learning, where you don't have to build everything from scratch, but you can reuse the great work done by the others. And in the end, we will create our own application, all of us. Yeah, that's the plan. And of course, we'll talk about the hackathon if there are any questions at the end. Let's see. Okay, this workshop today, we have a real case study, a real data set. We want you all, we'll take a very practical approach, this works, this doesn't work, and so on. We'll not be too theoretical. Anyway, in 2 hours, we cannot really do a lot of theory, which people study over months, right, over whole semester. So, but we'll keep it very relevant. The main things which matter, how it matters and why it matters, right? And we will try to relate things to solving a problem at hand. Okay. And of course, please ask questions in the chat or the Q&A if there is one. I will not answer them right away because there's too many, it's hard to manage, but I'll stop at maybe logical points or towards the end, wherever, and then we'll just see if, what questions we have. Okay. And the main aim, remember, is to create something tangible. And this process of preparation stored and basic operations on images and so on, right? Interpreting images. We will look at open some common libraries like OpenCV, TensorFlow, or Keras for computer vision tasks. There's many tools, but we will stick to these two. We will build our own model from scratch. We'll do that also. We will also use transfer learning to use some state-of-the-art existing model and use it for our purpose, right? In the end, we will create our own project essentially. And in the project, we will also have a nice interface where we can do something like a small project, right? With the user interface in the end. Okay. Right. So let's first discuss the case study because this is the main thing. This is what we are really trying to solve here. So we start with the problem at hand and then we see what we need to solve it. And the problem, as many of you already know, is automated traffic sign classification using computer vision, right? That's the problem at hand. And what does the data look like? We will look at it again in great detail and so on. We will look at it through code, each of these images. But essentially, we have a data set which has many images of different categories. And there are different kinds of signs over here. So if you see the one on the left, which I'm circling with the red dot, that is the sign which says the speed limit is 5. There's this other sign which says do not take a left, right? Just don't take a left. This one says don't take a right. There is a which is no entry sign. There is a speed limits. There is a clear way for car has ended. So there's many kind of signs really in this data set. And what we need to do is help create a model which can identify these signs with accuracy. Why is this important? Which application uses this kind of a thing? There's many things, right? One is, of course, for self-driving cars, you need this. Yes. You said for self-driving cars, you need, okay, for them to be able to read the signs. Yes. So if you build a good model, if you're working on this, you can think about solving problems for self-driving cars. Yes, number one. Number two, there are applications I would say TomTom or even Google Maps and stuff, right? In many cars now you have systems, but it's not self-driving cars, but you have these smart systems which tell you what the speed limit is because you're driving on the road, you don't notice the sign, right? But the car detects the speed, the different signs, and tells you if you're exceeding the speed limit or not, right? That's what I have in my car, for example. So there are many applications. What the output looks like, we will create a simple app. We'll share this link with a friend or family or whatever. They can upload an image of traffic signs from wherever they want to. And when they click on submit, they will get an output saying that, okay, this looks like a speed limit sign with a 5 km/h speed limit, right? It also, I mean, it's up to us how we want the output. It also gives you the next best guess. In this case, it is 100%, but yeah, still. Point is, we can do this kind of a thing, and it's such a nice thing, right? You have an output, you can add images, you can click on something, you can get an output, you can share it with other people, you can create demos out of it, and so on. So this is something really cool, and we will see that this is not difficult. In fact, we will build something like this. And in fact, when you do your hackathon submissions also, wherever it is relevant, right, we would like you to create such demos. Right? So that's the whole point. All right. So let me see. Yeah, I see that the voice is breaking. Is the voice fine now?
Yes, Mirza, it was breaking and there was some lag in between,
Okay.
but now it is better. Yes.
Okay. All right. Okay. Let me then continue. Okay, so this is the output, folks. You will build a traffic sign detection app, a link which you have practically deployed, and you'll be able to share it with anyone, try it out yourself. Okay. Question, are we going to train on the specific limits or any number in the board? I don't know what you mean, but there is a data set. Someone asked a question about what we will train on, but there is a data set. We will look at the data set and you will know what this means. Okay. All right. Yes. So let's continue. Okay. So this is the output, folks. This is what we're aiming for. And yeah, so then what is the task? The task that we have at hand today is image classification. And what does image classification mean? So image classification is one of the many tasks in computer vision. Yes. And there are many really. I mean, given an image, the first thing you see on the left is image classification. Okay, okay, there is a teddy bear in the image. Yes. The second thing is classification with localization, which is okay, there is a teddy bear, and this is where the teddy bear is. So you create these bounding boxes around the teddy bear. Yeah, so you know where also, not just that it is a teddy bear, but yeah, this is where the teddy bear is, right? Then you have image detection. Image detection is more like, okay, identify all the different things which are present, different objects or entities present in an image.
Hey, Mirza, your voice is not audible.
If you remember, what was there was some app, right, where you can take your
Hey, Mirza,
picture
can you
and
repeat the last line? Will again, your voice
ah,
was not audible then. It
okay,
got freezed. The video also
okay,
got freezed.
okay. I don't know why this is happening. Okay, maybe I'll change something in the camera side. Give me a moment.
Sure.
Maybe the camera is streaming in high resolution or something. Give me one moment, folks. I'll try to change something. Okay, I have changed certain things. I hope this works better now. In any case, I will speak a bit slow so that you still get what I'm saying. Okay. Or maybe there's too many people. That's why something is happening. Let's see. Okay. So where were we? We were talking about different kind of tasks. But let me just stop my video for a while. You're seeing the slides, right? So, okay. I think now it should be a bit better. Okay. Now, so we're talking about different tasks, right? And I think I was talking about some app which was very popular a few years ago, where you have an image, which let's say your own selfie or whatever, and you ask it to style your image the way Picasso would have painted it or Van Gogh would have painted, right? I forgot the name of it, but it was very popular. It was using actually neural networks. Yeah? So there are many tasks really, and image classification is actually one of the most core tasks really, so something like a detection also kind of depends on classification to some extent and so on, right? So classification is, let's say, the core task in computer vision, and that's like really the basis. Okay. And let me go ahead, and what we will do today is focus on classification, right? um, okay, and right away, so that we have, we make sure the setup is all right, and we are all um, set up with the code notebooks and stuff. Let's do the very first hands-on, where you can see how using modern tools you can do these single folder on Google Drive. Contain at least 4 files. Okay, your single folder should contain at least 4 files. All right. And what should the files be? You should have one. Okay. You should. Okay. Let me just give me one moment, folks. I didn't know this was so bad. Yeah, I think there is some network issue. Give me one moment. Maybe I will rejoin with a different network. Yeah. Just give me one moment, folks. All right. Is this any better now, people?
Can you repeat, Mirza? I think the voice was breaking a bit, but
Yeah, yeah. I was asking, I changed the network. Is this any better?
yes, yes, it's better.
Better? Okay, cool. Someone says it is worse. Okay, but I suppose it is better. But yeah, okay, let me continue. Man, okay. Let me. It is better. Okay, perfect. Just give me 1 second, folks. Okay, right. Can you hear me now?
Yes, Mirza, yes.
Okay, all right. So yeah, let's get coding. Let's do a warm up of coding. And I was saying you should have a Google folder with 4 files, and one should be this simple image called fur coat. Okay. Hush Malika asks, "Can I do in Jupyter Notebook?" Yes, Hush Malika, but I don't know if how big how powerful your machine is, but yeah, yeah, you can also do it over there. All right. Okay. So the fur coat image of something called RGB. Then there is a Jupyter notebook. There is a code notebook here called CV_workshop. And there should be a zip file called traffic data. Both things. And it should all be in one particular folder. Okay. So I have extra files, so you can ignore the extra files. But yes, what you can do now is this. Okay. There will be a file called CV workshop v0.1. You can click on this and you can say open with. You should use Google Collaboratory. Okay. If Google Collaboratory is not visible right now, you should, I think, go for Connect Apps and then look for Google Collaboratory. Okay. So this is Google's free like access for you to run your codes. You have some compute as well. Okay. So click on Google Collaboratory. Arnav says, "Can I do Arnav wherever you think you have access to the internet? You can do it anywhere." Yeah. Up to you. Right. Okay, so yeah, just decide where you want to do it and fine, let's get started. Okay, cool. So one thing we want to do, folks, is first thing we want to connect to a runtime. If you're using Google Colab, if you're using some other system, do something. Okay, just make sure you have a working thing. You have a working folder also. Okay, now what I'm going to do is this. First, I am going to have a small file, okay, workout and RGB. I will take these two files and I will put it here in the window. All right. So I take fur coat and I drag and drop. That is one way to do it. And then there is RGB. I drag and drop. Okay. Now, once you have this, okay, let me see this question. How to open, please? Okay. So for those who are using Google Drive, again, remember, you go to this on the more actions, or maybe just do a right click and do an open with, and then Google Collaboratory should be there. If it's not there, you just look for connect more apps and you should find Google Collaborator. All right. So once you have that, you will get this thing open. Okay. This is where you will be writing your code. You will be running your code. Okay. And what does this have? I'll briefly talk about this. This in the center here, here, this is where you will write your code. Okay. This on the left, you see, you have these sections over here, table of contents. You click on this, you have the files open up. Okay, this is all your files. And this is your, let's say, the current environment, right? Where you can put things, and whatever things you put here are accessible in code. Right? That's the idea. Okay, you want to access these things from here. Okay, so quick question. Okay, have you folks done this? Are you with me? Just in chat, just say yes, no, or do a thumbs up or something. Are you with me? Have you added this to your environment? No? Okay, there are some yeses, there are some no's behind. Okay, I'll wait. I think I'll wait for you all to start. Okay. How to do again. Okay. So once you open this Google Colab notebook, right, what you'll have to do is on this files section, yeah, on this files section, you have to drag and drop your file, which you have. Okay. Or I think this is the best way. Just drag and drop your files to this file section. Okay. You'll get a message first that, okay, this is a temporary runtime, and if you close this, the files will go away. That is perfectly fine. Okay. But yeah, add these files over here. Okay, there are questions about recording. I believe recording will be done. So yeah. All right. So once you're done, just message on chat that you're done, or yeah. You can also work in VS Code. Yeah, you could work better. Okay. So people are asking about traffic file. Folks, we will come to the file soon. Okay. Until then, don't worry about the traffic file. First, let's talk of these files. Okay. Okay. So again, okay. So once and for all, folks, use whatever system you are used to. If you are used to using something else, use that VS Code or something else, your local machine. If you're not, if you're beginning, if you can use what I'm using. If you are more familiar with Colab or Azure, use that. Okay. The tool itself is not the main point, right? The main point is what we do here. Okay. So just use whatever tool and don't ask questions about the tool anymore. Okay. Like which should we use VS Code? Just use wherever. Okay. Now, once you have this in here, now you are ready to run some code. Okay. And the way to run a code. So what I've done is, so that to save time and to save errors and typing and back and forth, I've already added the code here. Okay. And there are some standard code stuff going on. I will explain these things to you also, what I'm doing in the code. And to run this, for you, those who are complete beginners, to run a particular, say, cell, this is called a cell, right? You can either press click and enter, or you can simply click on this play button, like a run cell. Yeah. So I just say run cell. And what happens is, if you're not connected to a runtime, here it will say, oh, connecting to a runtime. So you just wait for a few seconds, and then this will be waiting, and then this will run. Okay. So is this run? Are you with me? Okay. Cool. Now that you're done. Okay. Suraj sends something. It's working. Okay. Huh. How do I navigate to? You don't have to navigate to home directory. I think just go for files, close this, come back again. Doesn't matter. But yeah, make sure it is there in this working directory. Okay. Right. Now what we are going to do is, first, number one, we are going to load an image into Python. Okay. And there are, let's say, a dozen ways of doing this, but I'll use one simple way. Okay. Which is using this small function in Keras, where you say image.load underscore image. You specify which image you want to load. And you also, while loading itself, you do some sort of an image resizing. The image is rather large actually, so it will not display very well. So, but what we can do is, when loading, we can, when loading, we can reduce the dimensions of this and make it easy for us to see. So what you can do is run the next cell. And this is what it is. Okay. Okay. Now, have cameras on again. All right. Now, so what do we have now? We have this image. What is this image of? A fur coat, right? You know this from the file name also by now. This is a fur coat. Okay. And let me increase the font size a little bit. Is this font size big enough for you all, everyone? Okay, let's continue. Okay, so the fur coat is, this is the file we have loaded into Python, and we will soon see, exactly what is the structure of it is, and so on, the channels and everything. But for now, it is fine. Yeah. Okay. Okay, so some of you, if you have some errors, I think folks from Saras, does referencing image variable automatically display the image? Yes. I think there's a question. Yes, you see here, right? In this particular case, there's automatically, it displays. Okay, this automatically displays. There's a question, I'm not able to run it. If you have done this the way I've done it, Jarvis, which is in this working directory, just dragged and dropped these two things, it should just work. Just make sure you are running the cell before and running the cell after. Okay, just in that order. All right. So this is how you load an image file. And later we will see what exactly the file is like. Okay. But here's what we'll do. We'll do something cool. Okay. What we are going to do, if you go next, okay, there is only a few lines of code. Okay. 2 lines here and 6 lines over here. Only a few lines of code. And let's just run this. The first line, this will take a few seconds because it will download something, it will download a model. Okay, so it has downloaded a model, 87 MB. Okay, what did we do? What did we download? And we will come back to this again later. We downloaded one particular model called Efficient Net V2. Okay, this is a lightweight, high performance image classification model, which we are ready-made, which is a ready-made model we're using. Okay, we're not doing any training, nothing, no, nothing really. We're just taking this model, all right, and we will simply make a prediction. Question is, will we build any model from scratch? Yes, we will build something on scratch from scratch also. We will use a ready-made thing also. We will modify a ready-made thing also. All right. Okay, now let's then, once you have run this, let's simply run this next line. And what do you get? Okay, so it ran, okay, and there is this output. It did some things, some downloading, it's fine. But here is where the predictions are. Okay, and what does this tell you? First, it has a category for that image. Like it has identified this image as one of the categories is fur coat with a 91% probability. So the model says 91% chance it is a fur coat. Okay. Second guess is cloak, which is only 0.2%, and stole is 0.2%, and bear skin and coat and stuff. It's point very low. But the model is very highly confident that this is a fur coat. Is the model correct? Of course, this is a fur coat. Right? And what just happened? Right? You took some random image. Okay. I mean, I just found it. I just searched for it online. I got this. And now here, with 6 lines of code, you are able to see what is in that particular image and correctly identify it as a fur coat. Now, that's something really cool. See, here you did not need to know a lot of deep learning at this point. Did not need to know a lot of coding, right? This notebook is with you. Yeah, this notebook is with you, and you are able to run this yourself, right? So there is this model which somehow has all this information. Yeah, it looks at the image and it is telling you, oh, this is what it is. So somewhere someone has trained the data, trained the model with a lot of data, and it also has seen fur coats. It has seen different kinds of categories of things and so on, right? It actually, we'll describe this later, but this is, we are actually using a data set which has more than 1000 labels, okay, for different kinds of objects. So there is a model which has been trained to classify different types of object, more than 1000 types of object, and you are now able to use it readily, right? And in a matter of seconds, with 6 lines of code, you are able to use that model. Okay, and that is powerful. That is the power of transfer learning. So what we did right now is we used a ready-made model from the internet, right? And this is one of the many, many models out there. Okay, okay, so, and it just took a few lines of code, no deep learning understanding needed. Okay. Priyanka says about the model, yes, we will explain all of these things later. Okay, but yeah, this is just a warm up. Okay, and we will talk about what is going on, what is the image shape of the image, what is the structure of the image, coming back. Okay, so hope all of you run this. Did you all get a fur coat as a top result? Yes, no? Okay, give me more yeses. All right. Okay, perfect. So you're all getting the same result. Perfect, right? So this is really cool, right? You're just able to get something and it works. It's magical. Okay, now let's go back to the slide. And now we have all the same setup. We have all the codes, notebook setup and everything. Okay? And one thing I want to warn about at this point is, so what we did, yeah, what we did is simply, in fact, we didn't even do a model fit. We just took a model and we said model.predict, and it worked. But that does not really mean that we are now capable of building any machine learning or AI or computer vision solution. Okay. A lot more goes into building proper solutions, right from data exploration to identifying the right train to identifying how it should be. Finally, you particular thing just to motivate. Yeah, I showed you one. I showed you one particular thing. I will repeat. I showed you one particular thing just to motivate. That there is so much power in transfer learning. That is not everything in computer vision, right? It's not so easy. So what we will do next is slowly understand those things, like what is an image, right? How is an image stored? How is an image represented? And so, right? Let's discuss all of these things. And the first thing, because some of you will have questions about what is image like and what are we doing in array and so on and so forth, right? That's what we will do first. We'll make sure you understand what an act to the workbook, to the notebook. Okay. And now we go to the section. Uh, we go to the section called anatomy of an image. Okay. We go to the section anatomy of an image. Okay. Are you ready? Okay. Okay. Now I can explain you what we are doing. Okay. First, we are importing a very, very useful library in Python called CV2, which is an excellent library for many, many computer vision, smaller computer vision tasks. Okay. A lot of image manipulation, image modification. So if you do not know deep learning, image processing stuff is very easy using CV2. Okay. That's the first thing we import. Second, something is uh, just a small function to display an image, which is using CV2. Okay, so this is just importing a library and importing a function to plot an image. Okay, okay, and now we will look at this. Okay, now you have the image RGB. Okay, you have the RGB image. And what you're going to do now is, you can also double click here and it will open up in the window. All right. So this is what your image looks like. It has three, let's say, it's like a pie chart with three sections, right? Three slices of the pie. One is red in color with R written, the other is green in color with G written, and the third is blue in color with B written, right? This is your image. And the first thing we'll do, after running this, okay, let me close this and close this. The first thing I'm going to do is read this image into Python again. Like I said earlier, there are like dozens of ways of doing this. Right now, we will do using CV2 because we want to use some useful CV2 functions. All right. So now let's run this particular cell to read the file. And there I'm using something called shape. Okay, shape. I want to see what this shape is and run. Vishruth asks, what should the code be if I am using Jupyter Notebook? Vishruth, within CV2, you directly have something called cv2.imshow. Okay, So this in Colab, you have to use a variation, but just cv2.imshow works directly in your Jupyter node. Okay. Okay. Oh yeah. So for those who are getting an error that module cv2 is not found, then maybe you are not using Colab. Okay. And then what you need to do is simply this. Okay. Have a command in your Jupyter notebook, whether you say pip install, what was this? Python. Let me just check the name. Okay. Name was OpenCV underscore Python, I believe. Installing CV2 in Python. Okay. I think it's pip install OpenCV underscore OpenCV dash Python something. Yeah. So pip install OpenCV dash Python. I think this is the command. So if you do this command, pip install OpenCV dash Python, and run this, it should install in your environment as well. So what has happened is when you're using Google Colab, many things are pre-installed for you. So you don't have to worry about installing them. But when you're using your local machine or something else, right, not everything may be installed. So you need to install them. It is just do this, pip install OpenCV-Python, and it will read it. Yeah, it will run this. And after you have run this particular command, run this again, import cv2, right? And after you have done this, import cv2, and then you have done this, okay? cv2.imread.rgb py.shape. Now, this is the important part. What is py.shape? Okay, this is not needed. Py.shape is, if you see the shape written over here, is 316 by 314 by 3. Do people know what this is? Do you understand this? 316 by 314 by 3. Yeah. If you imagine a matrix, okay, this is what a dimensions of a matrix is. So there are, in a way, there are 3 different flat tables in this, in a way. Okay. There are 3 different flat tables. Each table, there are 3. Each table is of size 316 by 314. And what is 316 by 314? If you go back and if you see the image which you had downloaded, right? That image resolution is actually 314 by 316. Okay. So each pixel, each pixel in your image, right? Each pixel in your image, right, is a value in a table, right? So your image resolution is 316 by 314, and therefore this is 316 by 314. But what is with this 3 things? Okay, let's go there slowly, okay, one by one. What, I don't know what happened. 3, okay. Okay. Now, if I look at one of them, I take one of them, okay, I extract the first one. It's a single 316 by 314, okay? And what is this? See, if you had a grayscale image, which is the other word of saying a black and white image, right? You don't have colors. There, you don't have 3 channels. But when you have a color image, okay, when you have a color image, there are 3 channels, okay? So there is one matrix or one table for blue color, one matrix for green color, and one matrix for the red color. And how do you see that? This is how we'll do the next. Look at the next one, okay? BGR. So what we will do is we will use CV2, the same module. It has a function called split. Okay, function called split. And when you, what I'm doing is I'm saying CV2 dot split the image. The image is pi, and it will extract me BGR. B represents the blue channel, G represents the green channel and R represents the red channel. Let's run this. Okay. Now, let's look at, now I have only the R part, and let's just see what is there in the R part. Okay. What is there in the red part? And if I run this one, you should see something like this. What is this? Why is this part green and why is this part black and why is this part white? The reason is black and white, right? When you have this single table, it thinks of it as a black and white image. Yeah? And wherever the value is high, it makes it white. Wherever the value is low, it makes it black. Okay. So what this image, when you see this on screen, what it means is this upper pi is high in value. The lower parts are low in value. And if you remember, what was the upper part? The upper part was this. So the upper red part has become white, which means there is a high value, and the lower B and G have become black. So the red channel R, yeah, the red channel R is essentially stores the high values for red. Likewise, if I go to G and I click on this, you'll see the green part is now become white, which means the green part has a high value, red and blue have a low value. Now the blue part, finally, if you click on it, the blue part has a high value, the other have a dark, right? So each channel, really what it does is each channel stores where the intensity of blue should be high, green stores where the intensity of green should be high, and R stores where the intensity of red should be high. And when you combine all of this, in the last one, you can combine or you can merge all of this to get back the original image. Okay. So there are 3 channels in an image. That is why the dimensions was 316 by 314 by 3, right? There are 3 dimensions. Now, let me see in chat. What does high and low mean? So high essentially just means that there is, see, now data is stored in a table, yeah? And images, if you see the data in images is actually, it's normally a number value, either between 0 and 1 or between 0 and 255 or something like that. Okay? It's arbitrary, but many times it is 0 to 255. Oftentimes it is between 0 and 1. But the point is, when the value is high, it represents a white color, right? It is represented as a white color. When the value is low, which is, let's say, close to 0, it is represented as black. So this black channel really has, let's say, this blue channel has, for the blue parts, it has a high value, number value, and for the red and green, it has a low number value. I hope it is clear now. Okay. Now, the next part. Okay. So yeah, this is a very clear example where red, green, and blue are absolutely separated. But that's not the case in other images, right? You don't have images. Other images have a combination of red, blue, and green and different levels, right? So, but anyway, the lesson is that each image is stored, right? Each image is stored as a combination of the red, green, and blue values. And that together gives you the final color image. So just be aware of this whenever we are doing image processing. Okay. Okay. Sahitya asks, red, GB are 3 primary colors. How do we get the shape? Sahitya, just to clarify a question, red, the size of the image, this 316 or something has nothing to do with the color. This is the resolution of the image. So when you have a full HD image, it is 1920 by 1080, right? That is what it means. Okay. Pratyush asks, does changing the order of colors change the merge image? Yes. It expects blue, then green, and then red. If you change it, then you will have something else. Okay. Okay. Now, someone says, I'm still getting module not found error on VS Code. I don't know VS Code, what you're using over there. That is why I recommended using Colab, right? Better you use what everyone is using, otherwise you will have a hard time. And I don't know if someone else helps you debug, but it's difficult, right, with a large group room. So better that you use Colab. Huh? Okay, now next thing. Now that we know what an image is like, what is stored like, right? Let's also understand basic image manipulation. Okay, and what we will do is we will take we will take this. Let's run this. Okay. Okay. Is it okay? Right. We will take this. Just run these cells. We are getting some utilities, yeah, from Python, and we are again loading the fur coat image. Okay. The fur coat image is this big, 1707 by 1280. Actually, this is the size of it. But we should also be able to do manipulation. So, for example, resizing. Okay, you say I don't want the big size. I want height of 500 and weight of 500. Then simply you can use this function c.resize new height, new weight, and run, and you'll see now it is 500 by 500. Right, the size has changed, and you can show this. It is shown. Okay, one cool thing. Like this, you can do something like a normalize. What does normalize mean? So normally you have values between 0 and 255, like I said earlier. But you can say, you know what? I want image brightness to be a little higher. The lower parts also should become higher. The darker part should become a bit more brighter, right? I can go and change in the settings, or I can do something like normalize, meaning that the lowest value now will be 100. It will do a min max kind of a thing and change the values from 0 to 255 to 100 to 255. And as a result, you see the fur coat looks brighter. So earlier there were darker sections. Now the fur coat is a little lighter also. Yes. So this is what is happening. And finally, just to give an example, you can also do something like blurring of an image. Okay. So run this particular cell, and you'll see that you can also blur. So what I basically did was, it's like took a like a paintbrush of sorts, with a big paintbrush, and I just whatever pixels are there inside, I took an average of it. So it got blurred. Earlier it was sharper, now it is blurred, right? And there are many different kind of things you can do, folks, right? And I've added 2 links. There are this nice blog where there are some more examples, and there is this official CV2 tutorials where you have far more example. Okay, so this is this. If someone is getting error about none type, Raj, you have to make sure that your file is there in the right location. Yeah, it should be red. Question, can we blur a part of the image? Yes, you can. You have full control. Actually, I would suggest going through the official CV2 tutorial. You can do a lot, actually, a lot of this, right? Without even any deep learning, just this. Okay, now let's finally, just in terms of preparation, let's prepare our own data and see what our data is like. Okay, so what you need to do is this. First, you should have somewhere the traffic data, yeah, traffic data zip file. Yes. Now, on Google Drive, of course. Now, to use that, what you need to do is, on Google Colab, when you go here, right, click on Mount Drive. On this side, you have something called a Mount Drive. Okay. So I'll unmount this. Okay. No, thank. Okay. Yeah, we have to unmount. You have to click on Mount this. Okay. And when you click on Mount, it will ask you for a confirmation. Okay. Which do you want to use, this Google account or something? Just say yes and go ahead. Okay. So mount your drive. Okay. And once you mount, just let me know in chat that you're ready. Done? Okay. Right. Now what happens is, this file, you can go in your drive and you can identify where the zip file is placed. Okay. So for example, this traffic data is what I want, right? You can click on this, you can say copy path. Okay, you want the full path of it. So you can copy path and you can paste the path over here. Okay, where I have my path, you can put it based on your path. And what we will do is, because it is a zip file, we want to extract everything. So you extract everything. And when you do this, if you have done this, right, if it works, what will happen is in your working directory itself, you see now there is a traffic folder. Okay. So what do you do again? Number one, go to your drive. In your My Drive, after mounting, right, in the My Drive, you have to go and go to the folder where you have things for, where you have placed this zip file. Yeah. I'm not a robot. Okay. Okay. Now go to the zip file, traffic data, say copy path. Okay. The path of this. Once you have copied the path, place it over here, paste it over here in fpath. Okay. And once the fpath thing is done, then you should be able to run this. And once you run this, you see now you'll have a new folder called traffic. And now the traffic thing has two folders. Now we're looking into what is our data. Now it has two folders, data and test. The data folder is where we have the training data. Okay. And the test folder is where we have the test data. So what we will do is we will look at this data and train our model on this particular data. And the test one will be to check if the model is learning things properly or not. Okay, that's the idea. So this data will be the main thing. And this folder structure you see over here is actually a very common folder structure for which people use for image processing tasks, because image classification tasks, everything that belongs to one particular category, they put it in one particular folder. Right? So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15 over here. Okay. And you can open one of them, then go further, and you will see there's so many images over here. Yeah. You can just double click on any one of them. And you see this is the image. Okay. This is number 5. And you can open another one. So in this folder, everything should be the sign 5 in different ways. Okay. As you can see, it's all 5, 5, 5. Different sizes and different angles. Yeah, but all of this should be 5. Like this for everything, like this one, 11, right? 11, I don't know what it is, but let's see. It is, yeah, no left kind of a thing. Yeah, don't go left, don't go left. This is the don't go left kind of a thing. So essentially, the folder structure is this. For each category, right? Each category, you have a folder. And now you want to make sure you're using it. Okay, so now run this next cell, which tells Python, okay, my train directory is this, right? And test directory is this. And there's also a CSV file which has been created called labels.csv. Okay, so we will run this. Let's run this and then see the shape of labels. It has 15 rows and 2 columns. And if you look at the head, which is top 5 records, you will see it has something like this. There is a class ID, 0, 3, 5, and whatever. And then it is the name of the category. So 0, which you saw over there, right? You're looking at 5, right? It just confirms that 0 represents a speed limit of 5. Yeah. 3 represents a speed limit of 40. And you can confirm that by opening a file from, yeah, so 40. So that's what this data is like. Okay. And these are the labels. Now, what we will just do is just do some basic manipulation to index, forget about this. And we can just to be sure, we can run this. Okay. Which this is just taking one particular file, number 5005001, and printing it out. So the number 5 is actually speed limit of 60. All right. That's what this is. Okay. So again, what is the structure like? After you do the extraction, there should be a folder called traffic. Within traffic, there'll be 2 folders, data and test. We want data right now. And within data, there is one folder for each category. right? All the images within the zero folder will be about the same thing, which will be uh, speed limit 5 kilometers. Okay, that's the structure. This is a very common structure which you will use in many places. Okay, all right. Now, next, this is, you can skip, you can just go through all of this. Now, let's go back to our slides and we'll do some fundas of image processing now, the core fundamentals, right? And I'll be a little bit quick over here because, this is a lot of theory, right? And we don't want so much theory. We want to do like hands-on, yeah? Okay. Now, the fundamentals of image models, okay? And by the way, for those who are beginners, it's okay if you don't get all the details right now, right? You don't need all the details really. You need to know how to be able to use it. Plus, some things which I will share in the notebook also. Plus, I will share some nice references for you to go through, right? You will have a full idea. So don't worry if you don't get it right now completely, okay? Okay, now the most common type of network which is used for image processing is a convolutional network, a convolutional neural network, or CNN. What does it do? Okay, this is in the short of it what it works, but we'll describe each step one by one. Okay, there is an input image. Yes. Now there is the first step, the first part which happens in the process is that some convolutions are performed. What does a convolution mean? The convolution is a mathematical operation. So you imagine the square. The square goes over different parts of the image, like a scanner, right? Different parts of the image. For each part it scans, it gives you some sort of a number. Okay. And that depends on what you want to do. There is the most common thing is a convolution, but that doesn't matter. It's just simply a mathematical thing, right? Convolving basically. Okay. Now, okay. So what you do is first you take the image, you take the square scanner of sorts and you scan the full image, okay? And that gives you convolutions, right? And we will see the intuition of this in the next one. But these convolutions essentially are mathematical operations. Once you have all of these convolutions, then you reduce it in size. You do something called a pooling or something, okay? And finally, all of this information, after reducing information and so on, you put it into a fully connected network. What is this fully connected network? What is this? Imagine some water. Yeah. What is this fully connected network? Imagine it as just a series of logistic regressions. That's it. Like maybe 1, 2, 3, 4, 5 logistic regressions. Okay. So basically, there is, yeah, it's a neural network. The first part is convolutions, which are mathematical operations. The second part is pooling, and then there is a fully connected part, which is like a series of logistic regressions. Okay. Now, what happens in the convolutions? Let's look at that now. And why do we use convolutions? Okay. The first part is a convolution layer, like I said. Now, what does a convolution layer do? See, you see in this representation, the slide, I mean, we will just share the recording, of course. You can go through this in great detail. I have shared the links, right? I've also shared an excellent reference for you. You can go it on your own time. So there is this scanner in a way, okay? Think of it as a scanner. This is called a filter basically, but yeah, there's a scanner. The scanner scans the image, parts of the image one by one. And each time it scans something, it outputs a particular number value. Okay? That's how the scanner goes. And the output of this, the way you design these is that, it so effectively it eventually is used for feature detection. What it means is this. Ideally, how it works is, let's say you want an image, okay? And an image you have, let's say, different lines and edges and counters and circles and stuff, right? You can set up a convolution filter which detects circles. So when you run over this image, it will get a value of high value when there is a circle. It will get a low value if there is no circle, something like that. Okay. So it identifies patterns within the images. So this is like, these are like small pattern detection filters in a way, but an important operation. Then the second operation, which is used, is called a pooling. What does a pooling do? Pooling is like a downsampling. What I mean by that is it reduces the size of the result. So if you had this kind of a size before, right? What is this? 7 by 7? When you do a pooling, right? It takes a small window and gets a single value for that window. So it does a, now you have a 3 by 3. From 7 by 7, you got it to a 3 by 3. Okay. So this two things keep repeating in the convolution network. One, you go over the image to look for important, let's say, information, and then you do a compression of that information into smaller sizes. Okay. And this you do again and again. And the idea is through this, you are able to capture some very nice patterns in the image. Okay. That's the idea. Okay. And again, there's a link over here. You can go through this in great detail. Okay. But how do we use this? How do we use this thing? What we do in general is that you take the image, okay, and the neural network, the whole network, the way you have it, is designed in two parts. Okay. You can think of it as the front end and the back end. Okay. The front end goes through the images multiple times and gives you some nice patterns from the image. Oh, that there is a triangle here, there is a nose here, or whatever, right? Then those patterns which have been identified are sent into, let's say, a series of logistic regressions. And they take all of this information to give you a final output. So there are two views. One is the front end, where you have all the convolution filters and all the complex mathematics going on, right? Extracting features and everything, which is the feature extraction front end. And then there is a back end, which is the classification, which is simply now putting all of this into a logistic regression kind of a setup. And that's how you design. And that's what most of these models are like. Okay, there is a front end and there is a back end. Okay, now, and this is just one example. We will create something like this from scratch, but this is just one example. Okay, where you have a front end which has a convolution 64. This is how many convolution filters are used. Okay, don't worry about these numbers. You will create this from scratch. But convolution, and then there is a dense and dense and dense. Dense essentially means like a logistic regression. This is one example. We will create our own, but generally, the convolution neural networks have these two patterns. One is a front end for extracting information, and there is a back end for making the actual prediction. Okay. And let's see this. Okay. Let's someone asked, repeat the back end. So the back end, what it does is, this is the feature extraction part. The front end is really what identifies, let's say, triangles and let's say shape and edges and the nose and the eye and everything. Okay. The backend will take those markers about where a nose is, nose and eyes and everything, and identify that there is a dog in the image or not. Okay, and each layer, what is dense over here, right? Each one of them is like a lot of logistic regressions. Okay, and you have like 4,000 of them here, right? And then 4,000, and then 4,000, one after the other. There's a lot of mathematics here, like a lot of operations here, but that is very simply the idea. This part detects the features like eye, nose, and everything, and this part tells you that yeah, there is a dog there is a dog over here. Okay, that kind of thing. Okay, now let's go to our own CNN. Let's develop our own CNN from scratch, guys. Okay. Now let's go to the code notebook. What is to be done after copy path step? Okay, someone asked. So after copy path, Ashi, you have to paste it over here in the F path part. Yeah. And then you have to click on this run. Once you do a run, this part is only an extract. Okay. It just uses extract from the zip file, and the function is extract all. After you do that, you will have a new folder called traffic over here and something called labels over here. And that is what you're using now. Okay. And you just go ahead and run the code after this. Okay. All right. Now, once you've done all of this, now what we're going to do is this. We have the images in the folders, but we want to use them like a regular data set, right? So what is the way to do image data sets? There is a very nice utility in Keras called image dataset from directory. This is made for this kind of things. This assumes that, okay, there is a folder where there are smaller subfolders and it has files for one particular category. That is exactly what it is. Okay. But what we're going to do is this. Okay. We saw the file sizes are like 100 pixels, 90 pixels, 150 pixels, some are 200 pixels. But yeah, we will make sure all of them have a standard size, because then we have to put it into the model. Yes. We'll make sure they're all in the same size. So we will specify a 128 by 128 size. Okay. This code is doing just that. 128 by 128 size. Okay, we are telling this that the train directory is being used where the training data is, and there are some things like batch size 32. It's not so important at this point what batch size is, but essentially when the model is training, right, it doesn't take all of the data at once. It takes it in small batches. Okay, and then there is a validation split. So what it means is 80% of the data will be used for let's say training the model, and 80% will be just to see whether it is doing well on unseen data or not. Okay, so this whole section will create two data sets effectively. One will have 80% of the records, the other will have 20% of the records, and the 80% of the records is the one on which we will train the model. Okay, I have to run this command first, and then I have to run this particular command. Okay? And when you run this, you'll see it identifies, okay, there were 2,736 files belonging to 15 classes. Yes, 15 classes were there. 2186, 2189 are used for training, and 547 for validation. Okay, why the 80-20 ratio? It's heuristics. Basically, you want to reserve a big chunk for training, but you also don't want the validation part to be too small. So you can do 70, 30, 60, 40, 80, 20, but yeah, you can use 70, 30 also. Yeah. Anyway, now that we have this, and there's a small section of the code. What it will do is you also want to count how many records are present in each label, or how many images correspond to each label. So what I'm going to do is write a little code, and you know that within data, this is the folder. This is the name of the folder contains this. Yeah. If you're getting error, you have to run the other things before this one: train data and train dir and test dir. Only then this will work below. Yeah. Make sure you run the cells in order. Don't miss any cell from before. Okay. Now run this path. And what I'm doing now is counting how many records are in each label. So now what I see is label 28 has 342 records, 342 images, right? 55 has sorry, just some water. Yeah. And then you click on this. And what you see now is for each label name, how many images you have. So for bicycles crossing, there are 117 images. For speed limit 5, there are 97 images. For speed limit 60, there's 158 images, and so on. There's something called unknown 7, which has 87 images. So find out. Yeah, we can find out what this is. So 56 is unknown. So there's this code, just reads a image from the 56 to see what this is. Okay, and I saw this for the first time in this data set only. I have no idea what this is, so I did an image search, and it turns out this is actually means yield in Chinese. So in Chinese, this means give priority to the other car from the main street. Okay. So what we're going to do is make sure the label is also called yield. So I'm renaming the unknown 7, right? Now it will be written as, oh, why is it stopping? Okay. Yeah, now it will be written as yield. Okay. That's it. So this is now the label set. There was something called unknown. We saw it is a Chinese sign for yield, and we updated. Cool. Now let's build our model from scratch. Okay. And again, don't worry about what each of these things is doing so much. I will explain briefly, but the important thing is you run this, you go through this later, you have a whole other examples and so. Okay. So what I'm doing now is, how many classes do we have? We have 15 classes. Okay, 15 classes in this. And what I'm doing here is defining the data. Okay, there's a question: how do you make sure each image is of the category yield? So Jinsi, all of them belong to the same class. That's the design of the data set, right? So you can check more images just to make sure. But I did that check before, and it all belongs to the same class. That's the design of it. Here, what we're doing is we are importing certain things in Keras. Okay. And in Keras, what we are doing is, Prajwal, I think you have some problem with your network. Spamming me with voice not clear will not help. So perhaps stop that. It is distracting me from the talk. Yeah. Okay. So, so these are the different functions you're using. Earlier, I talked about convolutions. So convolution 2D, right? Convolution 2D is does the convolution part. Max pooling 2D does the logistic regression part of sorts. Yeah. Then there is input. Then there is, so there's multiple things, and you will see these later. But run this particular cell first, and then you can run the cell below. Okay. And what we are doing is creating a what we are doing is creating a simple convolution network. Okay. Let me check again. Okay. Okay, I will move to a different network in a minute, but meanwhile, you guys can run these cells. Okay. First, we run this, yeah, sequential. So what is happening is we are having an input layer. Then we are having a convolution, and so on. Yeah, this is what we're doing. So we're defining some model architecture, go through it later. And this, when you run this, you will see that this is what the model has. It's a convolution here, convolution, max pooling, whatever. It doesn't matter, honestly, at this point. What matters is that you have defined an architecture from scratch. Okay? You added layer one by one. So input, then there is a convolution, there is a max pooling, there is a convolution, there was a max pooling, you can add it, remove it, convolution, max pooling, and so on. Okay, that's the setup model with how many parameters? This is 7 million parameters. Okay, and what we're going to do is once the model has been defined, we are going to compile the model. This is just compilation, right? It's just a step of saying this is the final model, yeah, and these are the metrics to use. And there is a small thing. Small thing I've added. This will be useful for you later. You're running the model, you're training the model. It takes a lot of time, but 50, 60 iterations. Okay. What we want to do now is don't wait for full iteration to run. If there is no improvement in the results, then don't keep running. Just stop after a while, right? This is what the early stopping is for. There is a question, why sparse categorical entropy loss? Okay, yeah, because there are 15 different categories, right? And sparse one is efficient, right? For large data sets. So we use 15. We use sparse categorical cross entropy. Okay, so just run this one and run the next one as well, where you are telling this is a train data, this is a validation data. Run it for 10, let's run it for 2 epochs, and later you can run it for 20 on your own. Okay. And run it for 2 epochs. Just run. I will, okay. Just run this and it will take maybe 2 or 3 minutes. Okay. Just run. Yeah, I'm not saying anything. Okay. I'm just, okay. So did it run for you? Is the run complete? Yeah. Okay. Now you will see, actually, you can run it for more later, but you'll see that it has given me a validation accuracy of about 83%. This is not very impressive actually, because I know this data set. You can easily go beyond 90%. Okay. But all you need to do is run it for more epochs, make it 20, make it 50 or whatever, right? It will run. Obviously, it will take more time. We don't want to be waiting for it. Okay. So that's how you make your own model from scratch. And in 2 epochs, we got 83%. If you do 5 more epochs, you will go around 90% for sure. Okay. So this model, this is doing fairly well actually. This simple model is doing very well for this particular data set. Okay. So that's how you build a model from scratch. Just let me remind you. Okay. It's a very simple thing actually. Once you have the data in place, right? Once you have the data generators, which you have over here, very standard code, nothing to think about really. Then there is this part where you are actually doing the model definition. You say you initiate the sequential model, then you add layers one by one. This is the input part, and there is a rescaling, like make it between zero and one kind of a thing. Then there is a convolution layer you added, then there is a max pooling you added, then there is a convolution, then there is a convolution, add, flatten. So this is the thing. This is a very basic way of doing this, and very standard code, folks. Nothing special over here. And you can have a look at this later. I will share the links as well. You can just add more, remove some of them, and change this architecture also. Okay. Now, this, and with just 2 epochs, you are able to get 83% accuracy. Okay. That's number one. That's pretty cool actually. And we did not run it for longer because it will take too much time. Okay. But yeah, let's go back. Okay. Hopefully you're all with me. You're all able to run this. 2 epochs done for you. Yes, no. Okay, yes. Suraj, I think you have a question about the hackathon. We will come back to this later. Okay. Okay. So many yeses. Okay, cool. So if there is a no, then run this and just wait until you get the result and we will proceed. Yeah. Okay. Now let's go back to the slides. Okay. So this was the part about creating something from scratch, but you don't have to do something from scratch always. Okay. A better idea is using something someone else has already made and done the hard work. So, for example, when we did in the beginning for the fur coat, we did not train our own model, right? We used something which was existing. That is transfer learning. So, transfer learning essentially is, in normal machine learning, what we do is, we, for each particular task, we have a separate model and we train on that data and so on. But in transfer learning, what happens is there is a task, a source task, and there is a lot of data on which this has been trained. And the knowledge in the model can be used for some other task also. So, for example, we saw a model which which could identify 1,000+ categories, and we used it for our own fur coat, right? So you can take something, train on something else, and use it for your own setup. And that's the idea of transfer learning. And why transfer learning? What is the benefit of transfer learning, right? One is that you don't need a lot of development to get a baseline, right? Because if you saw, right, with just 6 lines of code, we could identify that there was a fur coat, right? That's how quick this is. And your learning speed has increased because now you can, to have something working, you can use transfer learning. And this is why we are discussing this, by the way, folks. For your hackathon also, right? You don't necessarily have to develop everything from scratch. Maybe you can use something existing, but of course you will have to make sure you do some manipulation for your own, particular project. But the point is that largely you don't have to do all the, thousands of hours of training on GPUs using millions of dollars. That's already done. You can simply use that, right? You can already have this baseline models. Okay, and you can actually create solutions with little or no data. This is really, really cool, right? And you can access state of the art. So also called SOTA. You can access state of the art models with just a few lines of code. We saw it earlier. We got efficient net V2S particular model with 6 lines of code. Yeah. That's the benefit of transfer learning. The problems with transfer learning is that if your source and target problems are similar enough, then you can make it work. If they are very, very different, it doesn't work. So, for example, let's say there was something which was used to train, let's say, fashion items, right? This is a fur coat, this is a shoe, and if you're trying to show it, chest X-ray to detect lung cancer, then that's not a good idea. Yeah. Uh, then fine tuning. Sometimes you say, okay, no, I don't want to use it exactly as it is, but you want to kind of like, okay, use parts of it and change some parts of it. That's called fine tuning. That's something we can do, but it can be complex, but we will see how to do it. It is prone to overfitting, meaning that, for a small task, you can have a huge model and it could be overfitting the small thing. And also there is the idea of bias where, if the model was trained on bias data, then you are using a biased model, something like that. But still, regardless, transfer learning is amazing. And there is a link I have shared with you. This will be useful for you all later. If you want to see what is the state of the art model for a particular task, you can go to this particular link, which is paperswithcode.com. And there you have these benchmarks. So, for example, for image classification on a particular data set, these are the best models right now by time. So around 2020 efficient net B7, 2022 end of the year you have this efficient net L2. Now you have OmniVec, VIT, and so on, right? So many models are available, and if you go to this particular link, you will see the different kinds of models available, and you can decide, okay, maybe I should use this, maybe I should use that. Okay, so this is a one good reference for you to identify what the best models are right now. And once you've identified those models, where do you get those models? Well, you can get from multiple places. One, you could go to Keras. Keras, I have added a link over here. Keras has these many links, right? And it tells you also, okay, this is the model, this is the size of the model, this is the accuracy in the first result, this is the accuracy within so the first 5 results contain the in the main actual answer, right? This is the accuracy, this is the size of it, and so on. The Keras can be used, and there are examples also how to use it. So later you can use it. You can go to Kaggle also. Kaggle also has these models. So you see efficient net. We actually used efficient net V2, right? Keras has efficient net in the top, okay? So efficient net V2, and so on, right? We can also use these models, and I use one of them right now. Then you can also go to Hugging Face. Hugging Face also has so many models. You can get those models from there. You can download if you have an API, whatever. And finally, you can also do GitHub. So go to GitHub, and GitHub, you can search for repositories. Some of these are models. And I think if you don't know how to do that, just find some some tutorial on YouTube. It's very easy, actually. There are some commands which you can use in Google Colab or somewhere. It can easily copy some models from GitHub. Okay? But there are at least these 4 sources, which are the most common sources: Keras, Kaggle, Hugging Face, and GitHub, where you can get a lot of models, and you should actively look for your solutions on these places, okay, for your own hackathon. Okay, now once you know, okay, I have to use transfer learning, and once you know which model, and once you have identified that model to use, now you have to decide: do I want to use the model as it is completely? Do I need to maybe change the last part of the model only? Do I need to change significant parts of the model? Or do I need to just retrain the full model? That's an important question for you. Okay. And you can do this very easily. I will show you in the code. It's very easy to do this, but it's a decision you have to make. So when your data is small, what you do is, when your data is small, right, you don't change the entire model. Only the last part, maybe last 2 layers or something, you change. So basically the last part of the model is what you change. You say, okay, whatever the model has inside, the knowledge that is important, I don't want to throw it away. I will use the last part only. I will change the last part only to make sure it is working on my data. Okay? Because let's say you use something to identify 1,000 classes, right? 1,000 categories. but your data has 15 different categories. To make it work, the last part definitely has to change, right? To 15 categories. Otherwise, you can say, okay, I want to change the last 3 or 4 layers. That's at the top of the model in a way, right? Last 3 or 4 layers, only that part. Or you can say, okay, I want to change everything, but only slightly. And that you do when you have a large data set with you. Okay. If you have a small data set, you don't do this. Yeah, but this is one general approach. In your cases, if you have small data sets, mostly you are better off doing small or medium, right? Either a final layer change or an intermediate layer change. Okay. And this we'll see in code also. Okay. Okay. Let's now use efficient net models for our own particular task. Okay. And let's go back to the code window. All right. Now use fine tune a state of the art model. Okay. Right. So if you're here on the chat window, if you're here on the code window, what we're doing is we are reloading the images. Why? Because this time we want to use a different model which has a different image input size. Okay, and that's what we do over here. Just run this particular cell, and you're doing the same thing again, but this time with a different size. Earlier it was 128 by 128, but now you do 224 by 224 as the image size. Okay, this is bigger images. That's it. And now I mentioned earlier, there are multiple approaches to using transfer learning. You can freeze all layers. You can freeze a few layers. You can train everything, also, whatever you want, right? So there's many ways of doing this. So for example, if you do this one, okay, from Keras applications, import efficient net, include top is false. So include top means a final, place where it identifies 1,000 categories. You remove it, it is false. Once you do this, you have a base model in place. Okay, so run this. And now it will download the model. It will take a few seconds. Done. Okay. Now, if you want to say, if you want to say the model which you downloaded, it should remain as is. I will only add the final prediction layer. So for example, this one, okay, only the final prediction layer over here. Okay. Then what you do is say everything model trainable is false. Okay. Everything else, so only the final layer which has the identification of 1,000 classes, right? Only that is removed. Okay, the final output layer is removed, but everything else is retained as is. Okay, and then we add our own final layer. Second approach is you say, okay, I don't want to change everything, but I want to change the last 5 layers. So what I do, another option is, okay, make everything trainable, and everything except the last 5 layers is frozen. So only the last 5 layers are made false, right? So last five are, except the last 5, everything is frozen. Only the last 5 are trainable, right? This is another way of doing it. So this is how you can easily control how much of the model you want to change. In our case, what we will do is we will simply add a couple of dense layers in the end, right? We will make the model trainable false. Okay. So the same thing, just run this particular cell. And now what will happen is the same thing. The model is downloaded. We have set the shape as 224 by 224, model trainable false. So this was the base model. Okay. And what we're doing now is on top of that, okay, on top of that, efficient net is now, yeah, we are adding a dense layer with 128 and a final dense layer with 15 classes. So we are adding only 2 dense layers now, and everything is as is, and we are not really changing much in the model. So if you see, this is very close to this second approach, or maybe the first approach itself in a way, right? Freeze everything, add 2 of our own layers, including one for the final output. And then this is run this, and this is the usual stuff. Okay, you have the model update summary, and you'll see in the model, efficient net is there, right? Then there is a dense and there is a dense. And the interesting thing, the useful thing is, see, the trainable parameters are only 264,000. Earlier, we had 7 million parameters, and now we have only 264,000, right? 2 lakh. It's not a small number. It's a small number. Yeah. So that's what we're doing. So now you run this, and now you do the same thing, compile and update and so on. Okay. And this is compiled. By the way, I also added some code for your reference. If you want to train everything and not only the last two layers, then you can do it with a very small learning rate, which is okay. So if you get okay, someone said shapes are not supported. Yeah, Rohit, then you have to make sure the shapes over here, right? 224, 223. This is make sure you run everything in order. It should work fine, right? It is working for everyone. Okay. Now here the callback like earlier, same thing, nothing special. And I'll just do one epoch here and one validation. I think one epoch here. I think it doesn't matter, but I'll just do one epoch here, and it will give some very weird result like 100% accuracy. It doesn't matter, but still the point is later you can do it yourself. Okay, so I'll do one epoch over here. It will take a while. Okay, but when you're doing your own thing, depending on how big your data is and how much you are doing this, right? Make sure you just be careful. See, for example, for me it is taking 1 minute 20 seconds, right, for a single epoch. If you train for 50 epochs, it is like 1 hour, right? So just be careful of it. And I don't know what kind of setup you have. You're using your own systems, or you're using collab, or you're using your college's lab, right, where there is a better setup. I would suggest go for the better setup wherever possible. If you have some cloud setup, I would suggest go for that. Don't try to use your local machines too much, because in general, right, image models are a bit heavier. So yeah, I mean, especially let's say one of you decides I want a big data set with 100,000 images, it will be very super slow, right, working on local machines. So I suggest doing that. Okay. Anyway, so let's see. Let's run this. Let me see. Meanwhile, what do you have here? Okay. So this is the part where you're doing your own state of the art model, guys. I'm sorry. This is where you're taking a state of the art model and you're doing your own slight modification on it towards the end. This is going to be important base code for you if you want to build something of your own. Okay. And I've also added this other code. Remember, if you want to train everything, remember that you have to use a small learning rate and few epochs. Okay. Now, this will be done. Again, I used one epoch so that we can continue. But yeah, for you all, make sure you run it for more epochs and make sure you check the outputs and so on. Okay. By the way, just FYI, of course, try to make a good model for your own, let's say, solution. But again, just to remind you, don't worry about getting like extremely high accuracy and so on. That's not so important, really. Get something decent accuracy, and the main thing is it should work, right? It should work fairly, and then you can try to build a solution out of it and make a nice presentation. Okay, so that's that. Yeah, so we got 95% accuracy in one epoch, which is pretty impressive, right? And we used a huge model for this, but it's fine. Now, everyone with me? Everyone, this is running. It is done for you. With me, people in chat? Yes, no? Yeah. Okay. Cool. And now, once this thing is done, right, we have a model, right? All we have to do, remember what our goal was? If I go to the beginning, our goal was build something like this. Okay. You enter an image, it should give you a prediction. And that's what we're going to do now. And how we can do that? We will use something called Gradio. There are many things, Streamlit, this, that, many frameworks, but we will use Gradio. Okay. But before we do Gradio, we will just do a small thing just to make sure that we are able to use the labels properly. It's a small thing, just as an example. Let's take one particular image. Okay. Over here, just run this. You see number 11, category 11 is this particular thing. Do not, no left, something like that. Okay. What we want to do is in the labels file, right? When we go for number 11, like it should be sorted in such a way that, right, it should be sorted in alphabetical order in a way. That's what we want to do, right? So this is what we're doing over here. And this is just a code snippet just to do that, just to sort it in alphabetical order in a way, because that's the order in which, if you see the directories also, stored, right? First there is 0, then there is 11, then there is 14, right? So you're doing the same thing, 0, 11, 14, so that there is a match in the labels and the names, okay? That's it, that's all it does, okay? And you see, if a label's name, one should be don't go left, right? So 11 is 0 and 1, right? And it should be don't go left, okay? Cool, right? So now that's just basic manipulation, don't worry about it. Now we want to install the package which does the visualization, the user interface, okay? And we're using Gradio for this. And even though I said quiet, it is outputting so much, but anyway, doesn't matter, okay? Hide. Now, what Gradio needs is two things, okay? One, it needs a configuration, okay? That this is what the input is, this is what it should look like, the theme of it, all those things. That is number one. Whether it should, that is number two is there a function, right? What function should it use on the inputs? So there are two things it needs. One is a function, and second is the interface configuration. And we're going to create both. First, we will try. I'm just showing you step by step how we are going to the function. Okay. So assuming there is image. Okay. What is the image? Image was this. Okay. We want to resize the image because images are different sizes. Remember, user can also, if you want someone to input something, they can give you an image which is 1000 by 1000 also, right? But this model should work for any size. So what we want to do is make sure it is in the standard size 128 by 128 if you want to use the CNN model, 224 by 224 if you want to use the efficient net model. Okay, we will just do the 120 to 128. It is simpler. Okay, it's faster basically. So what we're doing is resizing the image. Then we are converting the image thing into a NumPy array. Okay, someone was asking why NumPy, why an array thing? We are converting it to a NumPy array. It's just a format, I think that's it. Because eventually we want it to be in this particular format, 1 by 128 by 128 by 3. This is what the Keras model anticipates. Okay, and then what we do is model dots underscore CNN. Remember, we built a CNN model earlier. We will make the model make a prediction. Okay, and let me just do this. Okay, and I'll show you what is happening. Okay, so when you say prediction, okay, and you run this, the image is resized and the model makes a prediction. If you want to know the actual label, okay, you can just use this particular one. Label's name argmax, which is okay. Was it the seventh label? Okay, seventh label. Or was it second label? Okay, second label, right? So why 1 and 3 in Empire? One means that this is a batch of size 1. 3 is RGB, if you remember from earlier. Okay. So yeah, 120 to 128, red, blue, green. Okay. Anyway, this is the, so this is, if you see the label, it says is don't go left. It does a good job. Yeah, this is perfectly fine. But if you want to also know what else the model thought is nearby it, right? You can do something like this. You can, instead of taking only the best or the final one, you can take the top few, or you can take everything, all the scores. Okay. And now if you run this, you'll see it will give you all the predictions for all 15 classes. Okay. And if you see now, actually, it says don't go left. It had identified as 61%, 61 point, whatever, 62%. But it's a 20% chance this is no car also, right? Which is no, why? And it makes sense because the no car thing also has a circle with a, let's say, yeah, with a cross in between, right? So that is why it is confused slightly. It's not confused, but yeah, this other thing is here, right? Earlier it was very confident about 99%, but yeah, now it is 61. So you want to know what the other things are also. Maybe top 3 you should know, right? So that's what this particular code does. It gives you the top, it gives you a score for everything, right? And not just the top label. This is very useful for us, okay? So now whatever we did over here, I'm just making sure this thing is in a small function. I've put this inside a function called classify image, okay? And this is the function we will use with Gradio. Okay, so run this function now. Okay, now this is a function. Function has been defined. So if you give it an image, it will give you what the classes are and what the scores are. And finally, what you need to do is, okay, now you have to do the Gradio interface. So remember, I told you Gradio needs two things. One is the interface, and the second is the function. the function is done, and now we do the interface. What are we doing? We're telling, hey, Gradio, I want to make an interface where you will input an image. The user will input an image. Okay. So this is the page, and we are saying, okay, the window where it displays the image should be 300 by 300. This is standard code. I've also added a link to Gradio. Gradio has a documentation. It has very nice examples and so on. Then I said this, instead of giving me all the labels or the top one, give me the top 3 classes. Okay, so I don't see only what it thought was the highest probability, but also the next 2, like you see over here. Okay. Okay. Then, okay, what is the function? Function is classify image. What is the input? Input is image, right? Then output should be the label type, which is number of classes. And there are some basic settings, don't flagging. There's a title I'm giving. What is a description? And there's a theme. Okay. And once this is the basic configuration. And once you run this, it will give you something like this. Okay. It will give you this link. You can open it here on bottom also, but it is better you take it to a new page. It gives you a nice little interface. Nice, right? So now this is our interface. Okay, Rohit, why are we using type PL? So Rohit, when you input an image, you can specify whether you want it as a numpy or a PL or whatever. I use PL because PL is easy to modify and reshape and everything. Okay, there's multiple options. There's no I use because it is just very easy to manipulate. Okay. Now here is where you drop or upload an image, and here is where you have an output. Okay. And what I'm going to do is in my downloads maybe, or wherever you folks can have it, wherever there is a traffic thing, there is a data, right? You can take something, don't go left or whatever class. I don't know if it will work, if it will work well, if it won't work well, I don't know, but let's see. And downloads, traffic, data, or the test data, maybe it doesn't matter. Okay, I pick some file. Okay, let me pick what do you want? Okay, let me pick this one only, 5. Okay, pick 5 and I say open, and you will see this is how it happens. Okay, and by the way, this you can take a webcam thing also, you can clipboard also, whatever, doesn't matter. So by the way, this is useful for you all later if you want to do something with the webcam or something with the yeah, and then say submit. Okay, and then see it did a wrong thing. Okay, because we trained it a little, but it did a wrong. Okay, but anyway, it says it identifies it has a speed limit 60. This is not so great. We can try something else or whatever, but it's not necessarily giving you the best output. But in any case, we didn't train it really well, right? We just train it for very small, right? So if you take this, it says okay, this one, it says okay, don't go left, 100% sure. Okay, fine, so it's doing a good job of it, right? Like this, you can basically you can have different images, you can submit different things. I don't know if this thing is here. uh, let me see something else. What is 26? Yeah, this particular sign is take right or something, go right, you do a submit, it says keep right. Yeah, so it is working for some classes, it is not working so well for some classes. I think what you will need to do eventually is make sure you're running the model properly. You train it for larger time. You see where the errors are occurring, right? You maybe try to do something about the errors and so on. Okay, but yeah, in the end, we didn't spend too much time on the model building itself, but when you build a better model, you should get better result. Okay, now this is your functioning app, right? And what does this app have? Now, very simply, you just upload an image, you can submit. In the background, it goes and takes a function, it uses the model to make a prediction, and now it has this. And with this kind of a setup, you folks can also make something of your own, chest x-ray image, upload chest x-ray image, and output will be whether there is cancer or not, right? Pneumonia or not, or whatever, right? This was something you can do as well. So just to give an idea how easy it is to build this kind of a small app. Okay, that's about building app. Okay, so what did we do, folks? We did multiple things, guys. Okay, and this is really cool, right? We, in fact, as I would urge you as homework, right? Take this efficient net state of the art model, right, which we had, run it for like 5 epochs or 10 epochs, and then use Gradio with this particular model. Yeah, and maybe you'll see a different performance. Okay, so this is how you do this. Okay, so you create a model, you see the performance, right, and then you can very simply put it into an interface. All this particular interface needs is two things. One is the configuration of it, of the interface, what it should look like, and second is what is the function, and what is the function and how that function should deal with the inputs which it takes. That's it. That's all. And with this, you can create your own app, right? Let me go back here. Okay, and that's how easy it is. Okay, so now hopefully you also feel confident that you should be able to build something of your own as well. Again, remember, don't worry about the accuracy so much. Try to get good accuracy, of course, but don't be so bent on, oh, I want to get 99.99 right, that you forget about the overall picture, right? But yeah, this is how you can build. You have a reference code also. What I also did is there are some more important topics, a little bit more advanced topics, I suppose, called data augmentation, batch normalization, and so on, right? I have added some snippets in this code notebook itself. You can have a look at it later, right? And you can use this to maybe make the model work better, just try to get a better performance. It helps usually. Okay? But yeah, that's that. I'll also share some links for you all to go through this. Okay, not just this, but also the learning material. Okay? And let me come back here. Okay, so yeah, next steps: go out there, use your skills, win the hackathon. Yeah, build something cool, earn zillions of dollars, and make a large donation to people who helped you, especially people who look like this, which is me. Okay, and if there's any questions about the hackathon, maybe you can ask me. I'll pause. I'll stay around for a while. Yeah, and yeah, just in general networking, staying in touch. You can add me on LinkedIn. You can ask me questions over there in general. So you can find my name on LinkedIn, or you can right now use your phone to scan this barcode and add me on LinkedIn. Okay, so yeah, this is it. And then finally, if for further learning, just for in general, okay, and not only for this particular hackathon, but in general, there's two recommend sources I would recommend. One is the CS 231 course, Deep Learning for Computer Vision. This is very nice for the theory part. I have added a link which also has the slides, the actual slides in that course. It is really very good. Yeah. Second, if you want a more practical hands-on thing, right, you can go buy this book by this extremely smart and really cool guy, right? His name is same as mine. It's a coincidence. But yeah, it's really good, right? I mean, I wrote this book, of course. But yeah, the way I have dedicated chapters to this using transfer learning, data augmentation, and so forth, and different design patterns and designing computer vision solutions and so on, right? So I just go and have a look. For $500 is a Kindle, 809 is the paperback version, so it's not a expensive investment also. Okay, so that's about it. I hope you all go further and learn, and make this, and stay in touch, and hopefully this gives you a good starting point. The code, you can use the code as reference for sure. Yeah, so yeah. Okay, now we have a few more minutes. There is some question. Will you please say how to add traffic data in zip file? I don't know what you mean, Navid. Do you mean, so zip file is already there? What did you mean? Do you mean using it in Colab or somewhere? Because you don't have to use it in Colab, right? I mean, what do we have to do in Hackathon? Okay, yeah, in Colab, you have the notebook. Just make sure you put the zip file into a folder and mount your directory. That's it. That's all. I think you missed the part, but if you do a mounting, if you do a mount, right, it actually becomes once you do a mount, your drive, right, your entire drive is available just like a folder. So my drive, for example, right, everything in my drive is over here. CV workshop is here, right? All my files is here. Okay, cool. Okay, now the question is, all right, how do we speak to this great person? LinkedIn, Shashank. Okay, now the question, I think some question is, let me yeah, if you want, you can unmute also, folks. Yeah, but let me see. I think there are some common questions. One question is, which is recurring, is what is the problem statement? What do we have to do in the hackathon? Okay, first thing, the hackathon is not like a Kaggle competition or something where a data set is given to you and you're just competing to get a higher accuracy score. No. What we really want in this particular hackathon is that you bring your own problem statements, think about problems you want to solve, yeah, and yeah, think about problems you want to solve, and you want to apply your knowledge onto problem statements. So ideally, you decide, okay, I want to work on something for healthcare, okay, and I have this idea that I can use image processing or computer vision to solve this particular problem in healthcare. So you will go and find some data set available online if you have it, or you can scrape the internet, right, to create your own data set, right? Maybe 50, 100 files or whatever, right? And so on. That's what you will do. Important thing is that you create a problem statement, you define, what are you solving? You make a working demo. That is very important. You make a working demo, and you make a working demo. Oh yeah, okay. I think someone has, yeah, Saras, the folks have shared the guidelines. Perfect. I think this is good. Yeah, you make a working demo. That's very important, right? And that's really, and like as I was saying, as it is on the screen as well. At the end of the hackathon, the team should make a working prototype. Okay, a simple front end like the one I made is enough, right? Just make sure that it is something which is working. It is solving some sort of a problem, right? That's the important thing. Again, I will reiterate that getting 99.9% accuracy is not the thing. You're not competing with others on the accuracy part. What you're really trying to compete with others is on how well you are applying your technical knowledge onto real world problems. Yes, the output should be a working prototype. That's the thing. So you can choose your own problem statement, you can choose anything, okay? But just make sure it involves computer vision and deep learning and the things we discussed, okay? So it is also okay to use other solutions, right? Which other techniques, but yeah, try to keep it to image classification stuff that we discussed, right? And there are many ways of computer vision problem solving, so feel free to use whatever. Just make sure, it works. It is in Python that we are able to evaluate this. Okay. Is there any other question? I think there are questions about maybe Hina, we could go through the slides very briefly. So others have some other questions also regarding these things. It's very clear. Okay.
Yes, yes,
Yeah.
right, Mirza. Lakshmi, can you move on? Yeah.
Yeah. Okay. Next one. Yeah. And this just to address what the judgment criteria would be. There's two parts to it. One is the project, what you will build during the hackathon, right? In the next 7 days, in terms of the code and the demos and stuff. Which is 70%, and the other is 30% is from the social engagement, because you know that part, right? What you share on social media and so on, that is the other part. But 70% score will come from the what you do in the code and the demos you make, okay? And in this, there are four things, okay? One is the creativity and originality, right? You were trying to bring some idea. You're not just doing a accuracy thing over here. You're trying to bring some idea. Okay, I want a fresh perspective. I want a new creative problem statement. That is very important. Second, in that it's a particular order. Okay, second is the implementation. It should be practically solvable in a way. Not perfectly solvable, fine, but even if you're getting decent accuracy, there should be some data set. You should be able to build a model, right? You cannot have a very theoretical idea. I think this will work. That doesn't work. Okay, so you should be able to get data. You should be able to do something, right, to make a working solution, because at the end you need a working tool, right? Third, accuracy. Now, again, the accuracy, like I mentioned earlier, it's okay if you don't have 99.9% accuracy, but it should still work. It should have a basic working thing, like, right? Sometimes it makes an error, but majorly it should not make an error, right? And by the way, when you use a particular data set from somewhere, you would also know what the existing accuracy is. So try to be in that benchmark, right? So for example, there's a data set, everyone is able to get 95% accuracy, and you're saying I got only 50, then it's not a good idea, right? But if there's a data set which is very, very challenging and people are getting 80% only, and you are getting around 80, which is perfectly fine, right? So accuracy is not the main thing, but it is a third thing, right? And finally, also, if you want you to treat this or develop your real world skills, and it is very important that you're able to communicate what you're doing. Sharing a code notebook, it will not impress me and the other judges. Okay, we just don't care. We don't care about your code notebook so much, right? What is the idea? how are you solving it, right? Communication of that idea, finally making a nice demo, thinking of the user interface, right? And giving a nice video demo of, okay, this is the problem, this is how we solve it. That will be impressive. Okay, so remember, just to summarize this, accuracy is one part of it, but the practicality, originality, and communication are also very important. And all of this amounts to 70% of the score, and 30% is still from your social engagement score. All right. I hope this answers many of the questions around, what data problem statement. There is no specific problem statement. You have to find your own. Do we have to do a video demo? Yes, you have to do a video demo. Okay, can we go on the next slide, please? Yeah. And then, by the way, I think there's a question about presentation. I will come to this point as well. Yeah, so submissions. Okay, so there is, now we are officially kicking it off now. Okay, this is where the startings happen. You now know what this is, and the tools and notebooks, everything fine. Okay, but there are some milestones in between. After this thing, first thing you have to decide is, form your team. Who are the people you want to work with, right? Form a team and identify what problem you want to solve, right? Quickly decide on this, and by 5th August, right, which is day after tomorrow, right, by 5th August, make sure to have a one-page document, right? And with that, in that one-page document, you should have the title of your project, what are you really doing, right? A brief summary, a high-level problem statement, and a proposed solution. And also also say, okay, I'm using vision transformer models to detect X in these kind of images. This is a unique feature, whatever, right? So just you can make sure, just give a nice idea of what you're really building over there, so that the people who are reviewing your submission, right, they are able to see the value in it, right? Because if they feel what is this rubbish, then they will not accept it, right? So there's an acceptance angle also over here, right? So make sure you're clearly communicating what you're trying to do. So one pager will be important. Plus there will be something else in the Google form also, right? So the Google form, you have to fill the details as required, and this will also contain things like the team name and the contact and so on. So that is a standard form. Saras folks will share that with you. It will be rolled out in the WhatsApp group. Okay. Next slide, please. Okay. Yeah. Keep your and the other important thing is, once you start, right? I'm sure this was the first session. You will have tons of questions, right? About your problem statement, feasibility or not, is this allowed, is that allowed, and so many things, right? But to help you all, what we will do is we'll have one more session in between, a 1 hour session on 6th August, which is a support session. And in that session, I will be again coming and talking to you, and I will try to give you some tips in general, how to, in a short time, how to find something which works, or how to technically make it fast and so on. I'll give you some tips over there, but also maybe answer your doubts, right? So keep your doubts and questions ready. Keep Put all your questions, or send all your questions in a Google form. And what we will do is, before the session, we will look at all the questions, and we will make sure all the common questions are addressed sufficiently. Okay. Yes. So before the sessions only, it is better you share your questions, right? So that your questions are not missed, right? Otherwise, it will be difficult. Shlok asks, can we go beyond classification? Shlok, stick to classification, so that it's standardized, right? Otherwise, it becomes a very different thing. Okay. Yeah. Now, final submission. After the intermediate thing on 6th, hopefully you will have your doubts resolved, and now you know exactly how you're doing and so on. Then the submission finally will happen on 10th August, midnight, effectively, which is Saturday midnight. Yeah. And of course, the final submission will also be through a Google form. It should contain these things you see on screen, like team ID, team lead, and you must have a demo video. We want you to do these things. We don't want you to be doing just code, folks. We want to prepare you for the real world, right? That's the whole point of it. This is why you have so many other things and not just code. We want you to prepare a video. We want to work on your presentation skills. Make a small presentation, 3 to 4 slides, okay, other than the thank you and team slides, okay, about what the problem is, what you did, right? Then a link to your code notebook, either in better that you have a code notebook itself or a PDF, but better you have a IPyNB notebook, okay? And finally, because social sorting is part of it, share your social media details as well for the post, okay? If you have have doubts about these things, there's a WhatsApp group, there's others folks are in touch with you, there's your community, there's college and everything. You have many avenues to ask the questions. Okay. And finally, I think it's one more slide. Yeah. Code of conduct, usual stuff, people. Yeah. I mean, there's a lot of these code of conducts people will share with you. Yes. But one thing I would like to highlight over here is that remember, right, you are now think of it as preparing for the real world, right? And the tendencies which you have in college or funky names and this and that and memes, and just avoid all of those really, because first of all, try to be professional. um, you will be judged by industry people like myself and the others, so we don't like casualness so much. We want professionalism over there, right? That's what you want you to prepare for. And secondly, remember that you'll be representing your college, right? So just make sure you're representing the college in the best possible manner, right? Don't resort to plagiarism. It's easy to detect actually. You think, okay, I will just go to GitHub, just copy everything and just submit it. It's not so difficult to catch this anymore. It's very easy. So you'll be very easily identified and you'll be disqualified, right? So yeah, remember this. Okay. Right. Okay. That's all, folks. Then let's see if there's any questions in chat. Are you sharing the notebook? Yes, it will be shared. Another question: work on only on classification? Yes, focus on classification, Ayush, so that there is a standardization. We are able to compare the things across. Okay. Shlok also asked the same question. I think Shlok also, okay, Shlok responded also. Okay, cool. So classification is resources will be shared post workshop. Yes. Again, remember 1 to 4 members in the team. Yes. Okay. And try to be creative, try to solve problems, think of the end-to-end thing, think of communication, right? When you form your teams, yeah, divide these tasks among yourself. And yeah, okay. Tanush says, okay, thank you, Tanush. Yeah. Okay. Okay. Tanush says I'm awesome. Yeah. If only I had $1 million every time someone said that. Okay. All right. Okay. Thanks. But yeah, folks. Yeah. Any
Yeah. So
questions? Anyone else?
any more
Over to
questions,
you, Vina.
guys? And again, thank you so much, Mirza. It was, again, I will
Uh,
say, an insightful session. So let the battle begin. So, yes, folks, I will share this presentation in the group description and the groups also. All the details will be mentioned in there. Be ready for the 5th August submission and 6th August doubt session. We will share the form
May I
links
ask
there.
something?
Sorry, who's speaking?
Yeah, I'm speaking. May I ask something?
Yes, yes, go ahead.
When the results will be declared, like after our submission?
So submissions, we will announce the winner announcement dates. It shall be probably 11th of August, but we will still confirm and share in the group all the details.
Yeah, okay. Thank you so much.
Yeah, no worries.
Hello, ma'am.
Yes.
What will be the prizes for winners and runner-up teams?
Yeah, we have rolled out the prizes distribution. So a prize pool of 2 crore INR is there, which is split up in different ends, which includes 1.25 cash prizes available for top 5 winners. Then we have some shopping vouchers to a select few, internship opportunities. We also have up to 70% scholarships on Saras AI degree programs. Then we have 10 lakh, up to 10 lakh fundings to some of the greatest ideas, and those come up flourishing through this hackathon, and we are willing to fund them also. And this, yes, there will be certifications to all the participants in the workshop. And still, I will share all of this in the group as well. Again, I hope all of you are a part of Clash of Titans group, and all of the details will be shared there as well, and you can ask any more questions up there. Yeah, regarding the social engagement, Soumya, it's mentioned again the guidelines. So 15% or 15 points is for pre this workshop, to post it on your LinkedIn account, and post this workshop. It is about 15% that you post the problem statement along with the proposed solution on your LinkedIn